Hi everyone, welcome to statistics. Let's start out with some definitions. A and B are mutually exclusive events if they cannot occur at the same time. Let's take a look at some examples. For example, being wet and being dry. You can't be wet and dry at the same time. Being hungry and full. Well, you can't be hungry and full at the same time. And you can't be underweight and overweight at the same time. If A and B are defined on the sample space, then the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B occurring. Let's start out by looking at the probability of a king or a club. That would be the probability of a king plus the probability of a club minus the probability that it's the king of clubs, or a king and a club, however you like to say it. Well, let's start out by taking a look at the probability of a king. Well, the probability of a king is 4 out of 52. There are 13 clubs in the deck, so there's 13 out of 52. From this, I have to subtract 1 out of 52 because there's one king of clubs inside a deck. Now, if I didn't subtract that 1, I'd be counting it twice because inside these 4 right here, these 4 kings, one of them is a club. And inside these 13 cards, one of those clubs is also a king. So when doing these, it's important that I'm following the formula when I'm asked about or. This differs from the ones we did in the last class where we did the and ones, where we had one event occurring. So two events occurring. Here we only have one event occurring. The probability of flipping a coin and having it land on heads or tails. Well, that would be the probability of heads plus the probability of tails minus the probability that it lands on heads and tails. Well, I'm only flipping the coin once, so there's a 1 out of 2 chance it lands on heads. There's a 1 out of 2 chance it lands on tails. And it can't land on heads and tails at the same time. It's only one flip, so that's 0 out of 2. This event right here is mutually exclusive. And when an event is mutually exclusive, of course, this value right here of them both occurring at the same time drops to 0. Of course, when you're doing an exam, you'll come up with a final answer, and you do have a calculator for that. The probability that it's a 5 or a red card. Well, that'll be the probability that it's a 5 plus the probability that it's a red minus the probability that it's a red 5. Well, let's take a look here. There are 4 5s out of 52 cards in the deck. There are 26 red cards in the deck, and there are 2 red 5s in the deck. Remembering, for all of these events, I'm only drawing one card, unlike when I had events occurring one after the other. So this is saying I draw one card. What is the probability that it's a king or a club? I draw one card. I flip one coin. What's the probability that it lands on heads or tails? Or flip it once, I should say. I draw one card. What's the probability it's a 5 or a red card? We're now going to take a look at the counting principle. And the counting principle involves something called the multiplication rule. If one event can occur in m ways and a second event can occur in n ways, they can happen together in m times n ways. Now, the one thing we want to realize is if there's more than 2 events, then it'd be m times n times o and alike. So for dinner, I have 3 choices of entree, I have 2 choices for soup, and 5 choices for dessert. I want to know how many possible meals can be ordered. Well, that would be 3 times 2 times 5, or 30 different ways. How many outfits can I make from 6 dresses and 2 pairs of shoes? Well, that'll be 6 times 2, which is 12. I'm told to make an appointment, and I can make that appointment on any weekday, either morning or afternoon. Well, there are 5 weekdays, and my choices are either morning or afternoon, so that's 2. And 5 times 2 is 10. Let's talk about permutation. So we're going to be looking at permutation and combination. A permutation is an arrangement of items with a specific order. You use a permutation to count items when the order matters. Where with n items you choose R, and order of choice is important. A combination rule, you're picking R objects from n total objects, when order doesn't matter. Start with n items, choose R order, or choice is not where choice is not important. I'm sorry, I should have said choose R when the order of choice is not important. I apologize, I misspoke. Permutation or combination, determine which of the two it is. Arranging paintings on a wall. Well, that would be a permutation, and the reason that's a permutation is when you arrange paintings on a wall, the order of the paintings will matter. Sometimes we put paintings in sequential order regarding our children going from their youngest age all the way up until their adulthood. This could just be in terms of size, or it could be in terms of style of painting. To finish first, second, and third place finishers in a race. Well, of course, order is going to matter in that case. Otherwise, the first place winner would be very angry when you gave the third place winner their trophy. Pick 3 members for a committee. Now, in this case, when you're picking 3 members for a committee, I haven't specified who those members are, which means all members are of equal rank. Therefore, order does not matter, and that's a combination. Lining up for a photo. Well, lining up for a photo, in general, what they do in most schools is they arrange according to height if they're lining one behind the other so that you can see each of the children in the photo. Lining up for a photo, order definitely matters because sometimes the parents want to be next to the children or vice versa. Selecting, and of course that's a permutation. Selecting president, vice president, and treasurer. Well, their order matters because a president, a vice president, and a treasurer are not equivalent. We're going to take a look at the formulas for each of these, and I'm going to solve the problems with this term called a factorial. So a factorial means that I'm going to take each number that precedes it and multiply it. So let's take a look at this by example, because that's kind of a mouthful. 3 factorial means 3 times 2 times 1, which of course is 6. 5 factorial would be 5 times 4 times 3 times 2 times 1, which is 20, 60, 120. There's one that you're going to need to make sure you know, and that's 0 factorial. And 0 factorial is equal to 1. This is described in math courses why, but in different types of math courses why, but not so much in statistics. We're now going to solve problems using the formulas and showing how I solve them by working them through. So let's take a look at those. I'm going to do a combination of 6, choose 5. Now in this case, 6 is where n is placed, and 5 is where r is placed. I'm going to plug into the formula that I'm provided. This is 6 factorial on top, because that's the n. R factorial is 5 factorial. And I have n minus r factorial, which is 6 minus 5 factorial. Order of operations states that I need to do what's inside the parentheses first. So that becomes 5 factorial times 1 factorial. Now 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. Underneath it I have a 5 factorial, which is 5 times 4 times 3 times 2 times 1. Now before you ask, the reason why I'm not writing in the 1 factorial is because 1 factorial is equal to 1, and anything times 1, of course, is itself. Let's cancel out all the like terms, and all we're left with is a 6 as our answer. So given this situation right here, I could have 6 possible sets that are formed. Let's take a look now and see what would happen if we did the same problem, except for instead of doing a combination, we're going to switch it to a permutation. Here, order is going to matter. I'm going to start out with 6 factorial on top, and then I'm going to end up with 6 minus 5 factorial on the bottom. Here, order matters. And I end up with 6 factorial over 1 factorial, which is 6 times 5 times 4 times 3 times 2 times 1 all over 1. And of course, for something like that, you can use your calculator, or you can do 30 times 4 is 120, times 3 is 360, times 2 is 720. So here we end up with 720. Quite a different number than we've seen when we're dealing with combination as opposed to a permutation, because when order matters, quite a few more combinations are possible. I'm going to move on to constructing a probability distribution. There are some above for you to practice on your own. And then there are several sites where you can plug it in and see if you've done them correctly. We're going to do constructing a probability distribution. I'm given a series of facts. One is that a probability has to exist between 0 and 1. You can't have greater than 100% probability of an event occurring, and you can't have less than 0% of a probability of an event occurring. The sum of all the probabilities has to be equal to 1 or 100%. To figure out the probability, we just do what's called the relative frequency we've done in the past. We have a total of 183 events occurring. And I want to know the probability that we're not going to have any siblings. Well, that would simply be 34 over 183. And then if I took a look at 81, I'd end up with 81 over 183. Now these answers can be placed in fractional form or in decimal form or as a percent. We've seen that before. What we're utilizing here is I'm going to start out by just simply placing them in fractional form. This should be 39 out of 183. This should be 18 out of 183. This should be 11 out of 183. If I were to add all of these numbers together, the summation of all of my probabilities would be 183 over 183. When simplified, they would equal 1. That's what shows me that this is correct and that I did my probability distribution correctly. If I had added these together and gotten something other than 1, I would know I was incorrect. Remember, in decimal form, the answer may come out slightly different, very, very slightly different. And that would just be due to rounding. Let's talk about expected value. Expected value is used to predict what we think is going to happen based on some percentages that we know. To calculate the expected value, we have to take the amount that we're looking at happening times the probability of it happening, and then we have to add them all together. That's what the sum means. Here we have 3 events. There's a 30% chance it will snow 5 inches, a 50% chance it will snow 2 inches, and a 20% chance it will not snow. What is the expected value? Well, I'm going to have a 30% chance of it multiplying by 5 inches. So I'm going to take 5, because that's my x value, times 0.30, because that's 30% in decimal form, plus 2 inches times 0.20, plus 0 inches. Oh, I'm sorry. I wrote the wrong number there. I apologize. Let me begin that over again. There's a 30% chance it will snow 5 inches. I wrote the second number incorrectly because I didn't read it. A 50% chance it will snow 2 inches. And a 20% chance it will not snow. And the reason I knew I was incorrect is because you always have to add to 1 by my probabilities. When I add these values together, 0.3 times 5 is 1.5 inches. 2 times 0.5 is 1 inch. And of course, that's 0 inches. So I end up with 2.5 inches of snow for my expected value. Chris invests some money, and there's a chance that he'll make money or lose money. This is a very common place when we're dealing with investing. It'd be nice if we knew these actual percentages. Usually people calculate them out based on trends and the like. Chris invests some money, and there's a 25% chance that he will lose $6,000. That's a negative. There's a 75% chance that he's going to make $1,600. What's his expected value? Well, let's start out with the fact of him losing $6,000. Because it's a loss, I designate it with a negative sign. I'm going to multiply that by 0.25 because there's a 25% chance he's going to lose that amount of money. Now, there's a chance he's going to make money. That's a positive number, which is $1,600. I'm going to multiply that by 0.75. Now, it's not enough to get an answer in a case like this. I want to kind of know what that answer means, because just having an answer doesn't always tell me anything. So this is negative 1,500 that I'm dealing with here. And then I want to take that 1,600 and I want to multiply it by 0.75, and you can do that on your calculator, and you'll get that to be 1,200. At the end, I have negative 300. So that means his expected value is going to be he will lose $300. Doesn't sound like the world's greatest investment. So I kind of want to always figure out not only what my answer is, but what it means in a case like this. Let's take a look at buying lottery tickets. Now, we all know that there's not much of a chance in winning in a lottery, but let's see what our expected value is. 2,000 raffle tickets are sold at a church raffle for $1 each. The three prizes are $500, $250, and $100. What is the expected value of your winning if you buy one ticket? Of your winnings if you buy one ticket? Well, there's several things that can happen. One is I can win the $500. I have 1 in 2,000 chance of winning that $500. But I don't win 500. I only win $4.99 because it costs me $1 to buy that ticket. There's a 1 in 2,000 chance that I'm going to win second prize. This would be $249. And the reason why that's $249 is because it's not $250 because I spent $1 on the ticket. There's a 1 in 2,000 chance that I'm going to win $100. So that's $99. Now this is 1, 2, 3. So if there's 3 chances of winning, then there's 1,997 chance that I'm not going to win, which is really not that great. So we always have a larger chance of losing than winning in cases like this. So we're going to lose 1,997 times out of 2,000. Now, if I were to add all 4 probabilities together, I would get 2,000 out of 2,000, which is equal to 1. And the amount I would lose would be $1. Let's see what that works out to be on our calculator. So if we take 1 divided by 2,000 and multiply it by 499, we get 0.2495. We do all of our values, we're going to end up with negative 0.4505, which rounds, of course, to the nearest penny because we're dealing with monies as negative 0.45 in terms of dollars. So I can say that my expected value is that I'm going to lose 45 cents or negative $0.45. Remembering again, I'm rounding to the nearest penny because I'm dealing with money.